Hey, it's Les with Judson, and I want to go over a couple of issues and tell you about Joe Brister sending me this CFM meter. Now with this CFM meter, we're able to actually see the true performance of what our machine really is and not what's claimed. Well, I'm kind of glad that we have this because I've always claimed that Judson's #1 Truckmount anyway. And so I kind of like to have this to kind of back what I say. You know what I mean? It kind of brings some credibility to it. Now this is Walt Bush's new truck mount we're building for him. He's allowed us to keep it a couple of weeks longer than normal, do a couple little things to it to make sure it's right. Like I say, it's our new green technology machine. It's a TNT that runs on LP. The engine runs on LP. It has a 25 horsepower engine. It has a 4M blower, or equal to a 45 roots blower, but it's got a Sutorbilt. And anyway, so this machine has a roots 4.5. So we're going to look here at the performance, and we're looking at, this is going to tell us what the true performance is of a properly designed blower and installation, or properly designed with no resistance in, no resistance out, and how that relates to more performance at the end of the hose. So we're running the blower at 3,600 RPM, and we can look at our spec sheets right here. And we know that at 3,600 RPM, that at 10 inches of mercury, it's 358. Now that's read here at the blower inlet, right here. So that's with nothing connected to it. I mean, it's 358 right there at 10 inches of mercury. And so that's what the CFM would be, 358. Now what we've done here is how we've always had the TNT design is the blower sits on the recovery tank, very short distance between the blower and the recovery tank, and there's no resistance, it's just an open, there's no filter right inside here. We filter coming into the machine. And then here we have here is a Stoddard silencer. It's a 3-inch, so we go from 2.5 to 3-inch, and that takes all the back pressure out of the system. We're tying the engine in with a venturi here, and then it comes on out and goes through the floor. But the video is not about the machine. I'll do another one on the machine. But what I want to show you here is that at 3,600 RPM, the CFM at the blower inlet is 358. So with 150 feet of hose on this machine, it's got a little over 9 inches of resistance, just the hose on there by itself. So we should get a little more than 358 at the blower inlet. But let's go down at the end of the 150 feet and see what we got. So I'm going to start the machine up. It's going to be loud because it's a video, but I'm going to try to make it fast, make a short video, so I'm kind of hurry through this. So what we're going to do, we're going to start it up full RPM. We're going to go get a CFM reading at the end of 150 feet of hose. And then I'm going to come back in here and I'm going to shut it off. And what I'm getting ready, what I'm going to do next, you're not going to believe what I'm going to do. So don't quit watching this video. So here we go. See, we got 100 feet of 2.5-inch hose, 50 feet of 2-inch hose. And Joe Brister sent us this little device here. So we're going to set this up, and I'm going to go ahead and we're going to see what the CFM is. So we got about 364, 365. So remember that number. Remember it's 358 at 10 inches, and we only got 9 inches of resistance. So it should be a little more than 358. So it did. It was 365. But wait, that's at the end of this hose. How could it be? That's the performance at the blower inlet. So let's go do the little special thing I was going to tell you about. So come on. Okay, so you saw that we had 365. I got one right here. We had 365 at the end of that hose. And the performance, 365 at the end of 165 feet. Now we're going to do something here, and I'm going to show you that when you have a blower installed with no resistance and a properly designed recovery tank, I'm just going to pull this off, try to do it real fast, get this off, pull that off. Okay, now that's disconnected, so there's our blower inlet. Now watch what I'm getting ready to do. I'm going to take this hose off here, and I'm going to come around here, and I'm going to connect it right here. So now, there's no recovery tank. So strictly the outlet pressure resistance, if any, which we don't have any because it's all 3-inch. So here we go, I'm going to start it up. And let's go see what the CFM is at the end of that hose. Basically what I want to explain what I just did. I showed you that a properly designed blower, it's possible to get the performance down the hose and to the wand, which is what we're trying to do to start with. Now anybody can build a machine with a big giant engine and a big blower. That's not engineering something. Engineering something is properly designed blower, engine, replacement cost of the engine, the operating cost. Now you get with this unit here, it'll maintain 240 degrees on a high flow wand under commercial carpet cleaning conditions. It will not drop, and it's around 1.8 to 1.9 gallons an hour to have that performance. If you want to match the performance of other machines that will not maintain 240 on commercial, turn this down, save some more money. You can get it down to about 1.5 gallons an hour. But what I actually did is I bypassed the recovery tank. So I just wanted to show you that it's got the same performance as at the blower inlet. At the end of the hose, it's the chart claimed. And also, when I bypassed the recovery tank and went directly to the blower, has the same performance at the end of the hose. So the recovery tank is not creating any CFM loss whatsoever. But I want to thank Joe Brister for sending me that meter. And I also want to give Joe Brister credit deserved, and he deserved the credit. He invented the cool cuff, and I believe in giving credit where credit's due and earned. I try to get a little respect for my dad because he invented the Truckmount. We got the patent to prove it, and it's kind of hard for him to get his credit due. So, Joe, I don't feel for you, but I'm really glad that you sent me this, and I appreciate you sending me that CFM meter. And without that, I couldn't have showed the performance of this machine. But thank you, Joe, and I appreciate it. Thanks for watching this. All right, bye.